Hi, before we go into our sample problem, I wanted to have some additional comments about the principal centroidal axes. So let's turn to slide 12. In the previous video, this slide, some of you might have seen it said the product of inertia is 0 when y or z axis is the principal axis. It's supposed to be and. So slide 12. IYZ is the product of inertia with respect to the y and z axes and will be 0 if these axes are the principal centroidal axes. So both of them, and. It's supposed to be and. So this is 0 when y and z are principal axes. So when IYZ is 0, y and z are both the principal axes. Let's turn to slide 13. The principal centroidal axes, what is a principal centroidal axis? They're the axes that go through the centroid and have an orientation for which the moments of inertia attain their maximum and minimum values. Okay, so if this is the principal centroidal axes, the axes will go through the centroid. Secondly, when you plug it into this equation, you're going to get a maximum and minimum for the moment of inertia. When the product of inertia is 0, then you will attain the maximum and minimum value for a moment of inertia. So how would you find the look at this equation? We would find moment of inertia with respect to the z-axis, a moment of inertia with respect to the y-axis. We would find that the product of inertia would be 0. So when plugging into this equation, this would go to 0, and you would get a maximum and minimum value for a moment of inertia. So this coordinate system would be a principal centroidal axis. However, let's look at the same cross-section, but let's look at a different axis. This axis also goes to the centroid. It's a centroidal axis, but it's not a principal centroidal axis. If we found moment of inertia with respect to z prime, this new z-axis and this new y-axis, moment of inertia with respect to y prime axis, we would find that this value would not be 0. So you would not get the maximum and minimum values for a moment of inertia. Okay. Let's turn to the next slide, slide 14. It's a summary of the concepts that we learned. First point, if at least one of the axes is a line of symmetry, you know immediately that that coordinate axis system is the principal centroidal axis. So if you know that at least one of the axes is a line of symmetry, then you immediately know that this coordinate system is the principal coordinate axis. So AXES is both axes are the principal centroidal axes. Okay? If there is no line of symmetry, then you need to use analytical methods or Mohr circle to determine where is the principal centroidal axis. Okay, so here, again, this is a typo on your book. There is no line of symmetry here. So you need, but this is still the principal centroidal moment is still on the principal centroidal axis. So how would we find what is that coordinate system? The principal centroidal axis system. You would need to use more circle or analytical methods. We know that this is the principal axis system because look, the neutral axis and the moment axis coincide. So the third bullet point, the moment axes and neutral axes will coincide when the moment axis is along one of the principal centroidal axes. So these two will coincide when the moment axis is along a principal centroidal axis. Okay, so this is a principal centroidal axis system. Okay, so let's move on to the sample problem.